All right, hello. This is 8-6, part 3, continuing with uh, solving rational equations. This is going to be example 3, and possibly also example 2. We'll see how the time goes. All right, so the first thing we're going to do here is we're going to look and see what n is not allowed to be. So what would make us essentially divide by 0? So what could n be? The denominators would be 0. And hopefully you can see in this case that that would have to be n equals 0. So we're just going to make ourselves a note that n is not allowed to be 0. So n is not 0. And then at the end, we're going to check and make sure that we didn't get 0 as a solution. All right, the next step is to figure out what our common denominator would be. So we have to have a 2 in it, and we also have to have an n squared. We have n squared here and n squared here, so we have to have an n squared in our denominator. And now we are going to multiply everything in the equation by that common denominator. So multiplying everything by 2n squared. So if we multiply this fraction by 2n squared, the n squareds will cancel, so we end up with 1 over 2 equals, not over 2, we're multiplying 1 times 2. The n squareds cancel, so we end up with 1 times 2, which is just 2, equals, and then with this one, 2n squared is going to cancel, so everything cancels, so we just have 1, plus this one, the 2's are going to cancel, so we're going to have n squared times 1, so that's just n squared. So then we just solve it. So we're going to subtract 1 from both sides, so we end up with 1 equals n squared, square root both sides, so we end up with n equals plus or minus 1. Don't forget your plus or minus, that's really important. So this essentially has two solutions, right? N could equal plus or minus 1, which makes sense because all of our n's are squared. So if I put in positive or negative 1, I'm going to get the same solution. So that makes sense, and neither of those are 0. They don't match our restriction, so we don't have any extraneous solutions. All right, let's continue on with example number 4. So with this one, hopefully, obviously, the first thing we need to do is we need to factor the numerator. Sorry, the denominator. You can factor the numerator. In fact, you might want to factor the numerator just to check and see if something cancels. In this case, it won't, but that might be a good thing to check when you're working on these, because if you can cancel something first, then you have a simpler problem to work with as you go. But we are also going to need the expanded version of the numerator later. So the only reason for factoring the numerator would be to check to see if something cancels. All right, so let's go ahead and factor that denominator. So that's going to be, I'm just going to write it below here. So that's going to be b plus 4 and b plus 4. So if you noticed that it was a perfect square trinomial and wrote it immediately as b plus 4 squared, that's great. Or b plus 4 times b plus 4. So now that we have that in factored form, now we can find our common denominator. Well, actually, before that, let's figure out what b is not allowed to be. So setting each of the factors equal to 0, well, they're all the same. So we can just see that b is not allowed to equal negative 4. b is not allowed to equal negative 4. So now we can multiply everything by our common denominator. So in this denominator, we have b plus 4 squared, and in this denominator, we just have b plus 4. So our common denominator is going to be b plus 4 squared. And we're going to multiply that by the whole thing, should be b plus 4 squared. So for our first fraction, one of the b plus 4s will cancel, so we end up with 6 times b plus 4. And then in our second fraction, both of the b plus 4s cancel, so we just end up with the numerator, b squared minus 7b plus 10 equals, and then nothing cancels. We have 1, nothing cancels, so it's just going to be b plus 4 squared. But I'm going to go ahead and write that as the expanded form, since I have the expanded form sitting in front of me right here. I'm just going to write b plus 4 squared in its expanded form, because I know I'm going to need that in a second. So you can write it as b plus 4 squared and then FOIL it back out. But since we factored it to begin with, we already have the expanded form. So I just went ahead and wrote it as the expanded form. Okay, so then the next step is going to be to distribute this. Distribute the 6. So we get 6b plus 6b plus 24 plus b squared minus 7b plus 10 equals b squared plus 8b plus 16. And now I'm going to get everything to one side, because this is quadratic, so I need to get everything to one side and then see if I can factor. Actually, on second thought, let's look at this. If I subtract b squared from both sides, b squared minus b squared, my b squareds are actually going to cancel. So this is going to end up being linear because my b squareds canceled. So I have 6b plus 24 minus 7b plus 10 equals 8b plus 16. Sorry for the things running together. I'm going to do some erasing so that I have more room to write. Okay. So since my b squareds cancel, I can now solve this as a linear equation. So I'm just going to get b's on one side and everything else on the other, and I can combine my negative 7 with my positive 6 here. So negative 7b plus 6b is negative b. 24 plus 10 is 34 equals 8b plus 16. And then I'm going to subtract 16 from both sides. So if I subtract 16, I'm going to get 18. And then if I add b to both sides, if I add b to both sides here, I'm going to get 9b. So 18 equals 9b. Divide both sides by 9. Right, divide both sides by 9. And I get that b equals 2. b equals 2. So b equals 2 is our solution. Checking that against our restriction, b is not allowed to equal negative 4. They're not equal, so b equals 2 is, in fact, a solution to this equation. If you have any questions, let me know, and I will see you in the next video.